Okay, this is a video to show how we're probably going to digitize the field boundaries in Tysoe. So let's just get rid of that processing toolbox for a minute. Stick it in there. Let's open up a previous project. This is where we've got the web mapping service, aerial photograph, and the Tysoe polygon. I'll turn off the aerial photography for a minute, just so that things can load a bit quicker, and we'll get ourselves down to around this area here. I'll turn the photography back on, so it'll load up in the background. Got to remember, every time you're doing something with the aerial photograph, it's pulling data in from the server in Warwickshire. So if you ask it for a lot of data, it will take quite a long time to do, as you can see. Okay, right, so let's start somewhere around here. So get to where we want to be. First of all, we need to choose a scale. A scale which is going to be appropriate for the work we're going to do. So let's look at how 1 to 2,500 works. Now this is a combination of what fits in the screen, what kind of resolution that fits in, and how you ultimately want to work with the data. And it's the detail and precision which you're actually taking. I have no idea what's just gone on there. I think my mouse has just gone slightly mad. There we are. Okay. So what did we say? We wanted 1 to 2,500. Fantastic. Now I just have got into the habit of just doing a little shift with the mouse button whenever I get into a specific scale. Okay, so let's start. 1 to 2,500 seems approximately okay. You seem to have a field here which has been cleared by bulldozing potentially. Right, so first of all, let's get our layer settings sorted out. The snapping options. Alright, it's 5 pixel units. Brilliant, it's remembered that. Okay, let's turn it on. Let's split features, and we're following the soft detail of this field boundary, which is a bit ephemeral. Okay, and what we're doing is probably just picking up this area of rough out here, but which is then carried on to this clearer boundary here. Fantastic. Now looking at this field, there looks like there was something in there beforehand, and again you've got this area of mixed kind of vegetation and possibly stone there, but for the purpose of this exercise we'll pull this whole boundary in. We can always subdivide later on. We'll stick a point on there anyway, just because we can. Go through these trees. We won't pick up that area of rough at the moment. We'll pick up this sweeping boundary which closes here. We will pick up this end point there for this field. You see here you've got the blue or purple in the middle. Click on, right click, and then we just pan to move along for the next bit. Fabulous. Okay. And the more that you do this, the more you realise that there's ways and means that you can make this somewhat more efficient. So what are we wanting to do here? Right, so it's back to splitting. So again, we see the snapping take effect there. It looks like there's a pathway or a track running down there. And at one time that field might also have been split into two, but without a little bit more ground data we don't really know. Again, there's a little track that seems to come down here and peters out, so essentially we can consider that to be the same boundary. Now we can just put in something across here that allows us to carry on the road. So just have this little polygon here. I know that may seem small and trite, but you'll understand why in a bit. So here, and let's just move up so we can see what's going on with this field. Does it actually run across here, or does it come down here and join up there? So we have the excitement of waiting to see, and it does go down there. Okay, fantastic. So here we are. Boom, 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 boom. So here, you can tie this in. So there you go. So on and so forth. Now you may find at some time when you're doing these narrow digitizing just like that, it snaps onto the wrong line. Okay. Let's see what we have here. Okay, so what it's decided to do is we have this polygon and we have this polygon, and it's created this little sliver in here. We'll get around that in just a little moment. So what we'll do instead, and this is why choosing a pixel rather than a distance identifier is much more convenient. So what we'll do is snap this out from this point, and don't worry about these things because they happen. Oh, that's because I've got everything selected. I need to deselect all. Okay, and then we start that all over again. Okay, and now what we can do is we can select both of those features, and you hold down Control to select them both. Then we can stitch them together on merge. So merge those selected features and just click on OK. So if we now look at this, we have this one over here and we have this one here. And so ultimately what we can do is end up joining that in with the rest of the road network. It's a subtractive approach, so you'll see that the road network will end up becoming left out as we digitize fields all the way around it, or urban areas. So just it's possibly easy to try and conceptualize how these different fields will look when you add these data together. So here we are. Okay, so we can add in more fields. Well, that's because I've only got that one selected, so we deselect all and start that one again. No matter how many times you do it, there are always going to be some traps that you fall into. So, excellent, and we'll pan up here. Enter now seems to be a reasonable time to take this road network and move across the road. And one way to get around this snapping problem with the roads is to offset your digitizing point. So we can put in another polygon here that captures this side of the road. Try and catch points which are at the end of polygons, which we'll use at a later point in time. Okay, so again we can go back to here and here, sorry, control click. So press control when you say it, and merge. Excellent. So once again we can see that's all one. We deselect all, get back into our digitizing, pick up on the point that we've chosen, and follow up. Now here we'll pick up this little copse. Add point there. Side of copse. So it's all quite easy and repetitive. The issue is to find a scale which you're comfortable at working in. And a visualization that suits you. So let's just add in this one here. Okay. Now we can save what we've done. Here's our save button. If you want to stop editing, you can stop editing. So if we go zoom to this layer, we can see what we've done with our digitizing. That's not really very clear. So let's change the way that this data is rendered. So instead of having simple fill, we will have an outline. And we'll change that outline to be a green, large solid line. Okay, so it's now much clearer what we've been doing. So even with a small amount of work, we've already made quite a lot of progress in relation to all of the area. So zoomed in. So again, we need to make sure that we've got a scale that we're happy with. 2,500 seemed good. As well as meaning about ensuring that the rendering worked appropriately, and that the aerial photography takes quite a significant amount of time to actually come in. So we turn the editing back on and we start digitizing. If you notice there, what I didn't do was leave a node in the right place. Makes it slightly awkward from the snapping point of view. It's always useful as well to have a decent quality mouse that you can control the precision of, because the digitizing itself can be really wearisome if you end up having to scuttle back and delete individual nodes. And so you just go on and on and on, like so. Ultimately, again, I hadn't put the node in place, which doesn't help. It can be quite rewarding as you see elements of the landscape become exposed, so you can start to see some of the structural components that really bring the landscape alive. Start looking at some of these field boundary rules. So, for example, the T-junction rule. We're coming to a T-junction here, which means that this part of the field respects this field boundary, and the implication is that this field boundary here is older than this field boundary here. So that's the T-junction rule. So the potential is that you could look at those relationships at some point in time and use it to characterize the relative ages of the fields to get back to the core ancient characteristics of the field systems. So these are the kind of thoughts that can go